So in this problem, we have what doesn't appear to be a quadratic because where there would normally be a variable, there is a binomial, x minus 5. So we're going to use a substitution. We're going to substitute for that binomial to make it a typical quadratic. We're going to say u equals x minus 5. Then the equation, when we substitute for u, becomes u squared plus 6u plus 8 equals 0. This we should recognize will factor. 4 times 2 equals 8. 4 plus 2 equals 6, that middle coefficient. So we know that this will factor to u plus 4 times u plus 2. So u plus 4 times u plus 2 equals 0. Which then gives us u equals negative 4 or u equals negative 2. And now we'll back substitute. If u equals x minus 5, well then x equals u plus 5. So x minus 5 equals negative 4, or x minus 5 equals negative 2. Add 5 to both sides, and we'll get x equals 1 or x equals 3. As always, we can check our solutions by substituting into the original equation. So let's do that with first x equals 1. That's going to give us 1 minus 5 squared plus 6 times 1 minus 5 plus 8. And we want to know, does that equal 0? So 1 minus 5 is negative 4. Negative 4 squared is 16. Plus 1 minus 5 is negative 4. 6 times negative 4 is negative 24. Plus 8. Does that equal 0? Well, 16 minus 24 is negative 8. Plus 8 does equal 0. So that solution checks. So what about x equals 3? We'll substitute in the same way. 3 minus 5 squared plus 6 times 3 minus 5 plus 8. Again, we want to know, does that equal 0? So 3 minus 5 is negative 2 squared is 4. Plus 6 times 3 minus 5 is negative 2. So 6 times negative 2 is negative 12. Plus 8, does that equal 0? Well, 4 plus negative 12 is negative 8 plus 8 equals 0. So that solution does check as well. So this shows an example of when we have a binomial in place of a variable, when we have any expression in place of a variable, we can substitute with a single variable for that expression to see if it will then form a quadratic that we can solve by normal means, whether it's factoring or the quadratic formula, or possibly even completing the square.